explosive plumes out of Jupiter to rising something like 3,000 kilometers out of Jupiter's atmosphere. It's huge. It's planetary-wide scale. What there was left was clouds that had been seriously disturbed over thousands and thousands of miles, seriously disturbed up to temperatures of tens of thousands of degrees.
Hubble's pictures of the comet impact prove that the violence that formed our planet billions of years ago continues through this day. In 2009, Hubble scientists have an epilogue to Shoemaker-Levy 9. Mysteriously, more black clouds appear on the surface of Jupiter. The pattern is similar to those left by Shoemaker-Levy 9 15 years earlier. Thanks to Hubble, scientists recognize such clouds as signs of a new impact. But there is a problem. No comets are in the vicinity. They conclude a large, uncharted asteroid is trapped by Jupiter's gravity. The asteroid crashes on the night side of the planet. The clouds from the impact remind astronomers of the dangers that still lurk in our solar system. But when they turn Hubble toward an empty patch of distant sky, what they find will rock the scientific community. In the winter of 1995, a series of commands are sent to Hubble's onboard computer that point the telescope toward the constellation of Ursa Majoris at what is apparently an empty part of the sky. Hubble's powerful gaze locks onto this single region of space for 10 consecutive days, creating a series of exposures that would be known as the Hubble Deep Field.
The Hubble Deep Field was a pretty astonishing idea. Take a telescope out in space and point it at one part of the sky and let it sit. Just take an exposure, and then take another one, and another one, and another one, and then add them all up. And what do you see when you do this? And you see galaxies. Thousands and thousands of galaxies. A crowded, dense field that looks like you're taking a picture of fireflies out in a field at night. And yet this is an empty patch of sky.
Every smudge of light in this Hubble picture is a galaxy containing billions of stars. These galaxies are captured at various stages of evolution. From a time near the birth of the cosmos to the rise of spiral galaxies like our own Milky Way. Scattered here and there in the Hubble Deep Field are the smash-ups of space. Galaxies crashing into and cannibalizing each other.
We estimate that there are hundreds of billions of galaxies in the universe. But it's only until you see that Hubble Deep Field and you understand that you're seeing a tiny little patch of sky. And yet it is filled to the brim with galaxies. And that's telling you that this universe is an astonishing and crowded and wonderful place.
The entire history of growth and change in galaxies is written in this single image of the Hubble Deep Field. What may be Hubble's most profound discovery cannot be seen at all, by any means. Something with so much power, it holds the entire universe together. For a number of years, astronomers like Kim Weaver have been surprised by the way galaxies behave.
Our observations of things we could see, like galaxies, weren't making a lot of sense to us. For example, how a galaxy rotates.
The arms of spiral galaxies seem to move faster than the laws of physics would allow. Astronomers spotted other oddities as well.
You can have clusters of galaxies that have hundreds to 1,000 galaxies in them. These clusters of galaxies are still bound to each other. The galaxies are still orbiting after all this time. Why are they bound to the cluster? There's something there creating gravity, creating the bending of space to hold these galaxies in place and to hold galaxies in their rotation that we're not seeing.
Astronomers hypothesize that galaxies are surrounded by a halo of unknown forms of matter. This matter acts like a glue that holds the universe together. They call it dark matter. Though we can't see dark matter, one astronomer has discovered a way to find it.
We took the Hubble Space Telescope and over 2 years slowly pieced together a mosaic of 600 images, tiled together a large patch of sky in which we could see about 2 million faint galaxies. And this was the Hubble Space Telescope Cosmos survey. It's the largest ever survey taken from space.
The survey reveals that stars and galaxies are born from ordinary matter, trapped by gravity inside clouds of dark matter. This 3D plot of dark matter clouds, charted by Hubble for the first time in history, shows how dark matter forms the very structure of our universe. Soon after the Big Bang, the gravitational scaffolding of dark matter formed the basis for evolutionary change throughout the cosmos.
We in fact owe our entire existence to this scaffolding that's set up of dark matter in the early universe.
As important as it is to our very existence, astronomers so far have no idea what dark matter is. This table shows us every element in the universe that we commonly experience on a daily basis. All of the physical matter that we can see, touch, taste, or feel is on this table, but not dark matter. Thanks to Hubble, astronomers find a way to locate and measure it. What they learn is that the universe has 5 times more dark matter than physical matter. But even if we add all the dark matter to all the physical matter that forms stars and planets and people, we are still missing about 2/3 of the universe. So what is the rest of the universe made of? Once again, scientists turn to Hubble for answers. Hubble Space Telescope is changing our understanding of reality. Adam Rees is part of a team of astronomers looking for the answer to a basic question. How is the universe changing? Since the 1920s, astronomers have known that the universe is expanding. They assumed that gravity would one day slow the expansion down, and perhaps even cause the universe to halt.
I know the universe is slowing down. The question just is how much?
The answer to this question would settle the debate about the age and fate of the universe, and it becomes a race.
There were 2 teams that didn't much like each other. They were trying to measure the rate at which the universe has been expanding at different times in the past and compare it with the rate at which it's expanding now.
The rival team of astronomers is closing on a solution.
There was this sense of competition and urgency to get to the answer. On the other hand, you wanted to be very careful because you knew that, if you got the wrong answer and they got the right answer, or vice versa, there would be a way to check.
The way to check comes from Hubble. It finds supernova explosions in remote galaxies and uses the light from the explosion as a yardstick to measure the distance from Earth to the galaxy.